Good day, my name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. We are now on our second part of the lesson on test of different thetas and FTEs from forecast to layout. So before anything else, statistical procedure intercept between independent dependent variable using Excel. The sample data here is for purpose of example and knowledge on the process of data analysis using Excel and SPSS. The data there are not normally distributed, the assumption. It's just for a point of example in the knowledge on data analysis. So the first step is to basically enter your data. You can do this in a spreadsheet or Word, and you have to remember that you have to convert them into codes already. So you didn't put male or female in gender. You assigned a code 0 and 1 because, as I've said, the calculating device can only calculate numbers, not words. And it will show you later. Okay, so step is enter your data. So we have our data here already. And next is to create a new sheet, copy paste for intercept data. So we want to use gender. As I've said, the variable here is consulting field. This is just for example. So we have gender and we have comprehension. So paste it here. What we need to do now is to set the groups. So next is sort. So you have to sort. And you highlight the data, click sort, sort smallest to largest. Always click expand selection. See that here. So we have, when you click expand selection, it will automatically, the second column will automatically be paired with the first column. So I have the 0 and 25, the 0 and 15, the 0 and 20, the 0 and 22, then the 0 and 17. And we also have the 139. Yeah, it will automatically, don't have to worry about it. The next one is expand selection. And here, we have to group the scores now. Remember, these are two intercepting variables. So assuming that 0 is male, and 1 is female, so these are the scores of the male. And that's the score of the female respondents. And there you go. So you have now the comprehension of your male respondents and the comprehension of your female respondents. And it's the same thing with other variables, except for intervals, which will be discussed later in a while on how to lay out intervals. From that, you can actually do data analysis now. You can just choose, well, I always choose an unequal variance because I don't know if the variance are the same. So let's say male, female, labels, output here. There, you already have your results. I'll discuss that further later because there are nuances that need to be clarified about choosing what variable is which variable to be chosen for variable A and variable one and variable two. Sorry for that. Anyways, let's now go to variable view in SPSS. SPSS is easier than Microsoft Excel, and input data and data collection can be considered fast and efficient. So from there, you have you can put male or female here, the numerics, but however, you still have to change them when you assign values later. So let's say you enter the data and it's still male, female here, and you edit variable view. So first is you enter data, type strings of respondents, string for respondents, numeric for others, with default, labels, default, or add, and the values of the values. So you have 0, you click on code, 0 male, 1 female, or vice versa. So it's in values that you put the codes, because SPSS will not do inferential statistics if there is no values assigned. It can do descriptive stat, but it's not going to do inferential stat when you don't have values. So this is, as I've said, even at Excel or SPSS, you have to be aware of what I've talked about of sequential progressive model, because this will have an implication later on in your data analysis. If you just randomly assign codes, you will have a negative R, a negative T, and you don't know what's going on. So I'll discuss that later on data analysis. So missing, you have default, columns you have default, align you have default, measure respondent as nominal, the rest are ordinal. So respondent is nominal, gender is, you have to assign it as ordinal because you already assigned the values of 0 and 1. That makes it ordinal. As I've said, SPSS is fast and efficient. However, if you don't know the basics, it will have a problem later on. If everything is so fast and you don't know what's going on already. So this videos will actually clarify those things, and always remember the lesson on sequential progressive model, because that's very important. We don't just randomly assign codes. We have to do some steps. So I think we can continue with tests with data analysis in Excel. So you already have now your data here. So you have click on data analysis. There are three options here: paired, two sample of means, two sample assuming equal variances, two sample assuming unequal variances. When you say paired two sample of means, you have the same, like pre-test and post-test, you have the same numbers. You can also use this one and this one, but usually use this one. And yeah, it will generally generate the same result. I always suggest to use unequal variances because we really don't know the variance of this data. So click on OK here, and let's change that one. Okay, so variable one, we use, let's show the process first. Since you put 0 in male, then on female, then alpha will automatically be at 0.5, 0.5. We'll just keep it as that, as blank, and we'll put it here. There. The problem now here is that you have a negative t. Why is there a negative t stat? What's going on? Well, basically, you just chose, you just, you, let's say, you just chose variable one without actually assigning it to male, without actually prior thought, or just randomly selecting it. We all, as I've said in progressive sequencing model, base it to your literature. We already, if the literature says that male or the female group has a positive scores in comprehension group, then you select female as your variable one. Same, I'll show you to you. So equal variances, we'll just switch this one. So by assumption, based on the literature, range 1 or variable 1 is assumed to be greater than variable 2. And we'll change that one to here and there. T is no longer negative. Same result, everything's the same, but the T hat is not negative anymore. This is because when you look at the mean, the same, it's male has actually a higher mean score than the female. And it will also show you the variance. The variance are not the same or not equal. This is, yeah, yeah. It can get complicated when you have, let's say, assumption this is your post test and that is your pre test. So doing the same thing, actually you can choose. You always assume that the first variable is higher than the second variable. So we assume that variable one, the post test, is greater, post test is greater than the pre test. So there, there, then put it here and there. Oh, it's negative because we inverse it. This should be the post test. This was the male and the female. Sorry about that. This was the male. So this one is your pre-test, and that is your post-test. So we'll have data analysis, variance. Our post-test is assumed to be bigger, higher than the pre-test, and there, the negative t is gone. However, if you did the same, but the mistake a minute ago, which is very normal. This is very easy, and you don't. Sometimes you are not aware of it, and it will create a lot of confusions later on. And I just want to make sure that that confusion error is not that much of a problem. It's just lack of fundamentals and the lack of knowledge on progressive sequencing model. And there you go. Everything's there. Yeah, I hope this discussion made things clear because in the book it's negative D. It really didn't discuss why. I think it will be discussed later on. So we'll go now to SPSS. So click on data analysis and t-test SPSS. So click on analysis and look for compare means and proportion there. Then put cursor on it and independent sample t-test. After that, click move variables to be analyzed to test variables. So you have your comprehension. So you're going to move that, click it at here and move it here. So your test variables, then click define groups. So your grouping would be 0 and 1. And enter the code 0 and 1 and click on continue. And you will have this result. Still the same, everything's the same, but as I've said, it's too fast and it may not, you might be confused on the number of data that will be released after calculation if you don't know what's going on or what happened. My research is destroyed. It's a negative piece. That's what's going on. It's just a minor error, but may have impact later on. You can always use the absolute value of t for nominal data, but what if that's a pretest and a posttest, or different variables that is not nominal at all? So note that SPSS can process multiple variables at the same time. Yep, that's one thing about SPSS. It can process multiple variables at the same time. You don't have to lay out. You don't have to just click, click, click. But in a few clicks as compared to Excel. However, results can be overwhelming. Thus, Excel is a good benchmark for learning. Essential data based on results. T-value in Excel, there's only one T-value. This is because one type of tool that is used, which is assuming unequal variances, as indicated in the result. The variance for female is different from male, is different from female. In SPSS, it calculates both T-value, one unequal variance, and another T-value when equal variance not assumed. Thus, if the variance is different from each other, then assume unequal variance is used for t-test. A negative t in a t-test based on calculation is 4.618. This means that the second group in perspective to 0 and 1 has a greater mean score compared to the first group. If the values or codes are switched to 0 female and 1 male, the result would be a positive t. Thus, it is very important for a data analyst to be aware of the effects of codes and assigned values. And number two, critical values. As calculated T, critical is present in Excel but not in SPSS. The implication of this is on testing hypothesis. However, p-value is sufficient to accept your null. So we'll be discussing this one before, and I have to change the to intervals for data analysis. We're dealing with intervals. So in testing hypothesis, one-tailed use greater than and less than as a measure, while two-tailed use equal or not equal as a measure. In this example, the hypothesis and the null are as follows. Hypothesis, male is greater than the female, and your null is male is lesser than female. The use of hypothesis male is greater than female is because of the sequence of codes or assigned values. You put 0 as male and 1 female. The hypothesis follows the sequence of code. In testing, the calculated t is compared with the tabulated t or critical value. Calculated t is greater than the tabulated t one-tailed. So if true, then you have to reject the null, which is male is less than female. If false, then you have to accept the null, male is less than female. In this case, is 4.618 greater than the female. No, I mean greater than 2.15. If false, thus the null is accepted. Male is less than female. This means in terms of score, male is less than female or female is greater than male. In the case that when assigning codes 1 or 0, 1 male, 0 female, the result will be a positive t. But since our codes are reversed, the hypothesis and null is also reversed. Thus, the female is greater than male and female is less than male. That's our null. So since the codes are reversed, we also reverse our hypothesis and our null. So by testing 0.416 greater than 2.015, which is true. Thus, since it is true, the null is rejected. Both have the same result in terms of testing, but can be confusing when there is no background knowledge on the technicalities, especially in awareness of assigning code. Yeah. So two-tailed tests use equal or not equal as a measure and test of hypothesis and null. Sample, male is unequal to female, the null male is equal to female. So the calculated t is greater than the tabulated t two-tailed. So 4.16 is greater than 2.571. If true, the null male is equal to female, and if false, if true, then reject the null male is equal to female. If false, then you have to accept the null male is equal to female. However, the result indicates that male is equal to female. If false, is female. Technically, in a two-tailed test involving testing involves the absolute value of t greater than calculated t is greater than the tabulated t. Since the absolute value of 4.16 is 4.61, thus 4.618 is greater, the result indicates it's true. Since it's true, the null male equals to female is rejected. Based on calculation, the male scores and female scores are not the same. That's a lot of confusion. Yeah, but you have to just, I'm switching paradigms. That's why it's so confusing. I'll discuss that later. No, just have to comprehend it one step at a time. But I'm not here to teach the complications of those nulls and hypothesis and reverse codes and everything and the absolute value. That's not the point. We can discuss that further because it's not clear cut. It's not a topic that you just discuss, then it's already there. The details here are already explained when you reverse with you're using one-tailed or two-tailed and with the code 0 and 1 and one zero male and one female and or zero female, one male. It's everything is there. You just have to do it step by step. And unfortunately, I'm not gonna discuss that now because we still have a lot of information that needs to be dealt with. But you can always reach out to me if you need help, and we'll go through that now and hypothesis and null because it can be very very confusing. But I'm not when testing. I just look at the p-value if it's significant or not. One-tailed, t-tailed. I look at the mean and probability value. So let's look at the probability value. Okay, so however, there's a deeper parameter that can be used. This is because p-value results can even reach to exponents. For example, the p-value 1 times 10 to the negative 5. This means that the p-value is 0.00001. That is significantly far from the threshold of zero point zero 0.05. It is suggested it is suggested to use this parameter. So if the p-value is here, that's highly significant, and from here it's significant, and from zero point zero 0.05 up, it's not significant. In this case, our p-value is this one. So one-tailed is post-test greater than the pre-test. Yes, it is highly significant. Is post-test different from the pre-test? Yes, it is highly significant. I wish I could discuss it in a certain way that it is easier. I think I've made this statement very technical in a sense, but can be confusing because of reverse values, reverse codes, and absolute values. But it's there. I'm sorry. I cannot explain it in a way that is like a panacea and that solves all. Because we have to look at data by perspective individually, and you have to have that practice of looking at data individually, repeatedly and individually to have that sense of mastery on looking at data. So yeah, I'll end this video for now. I will be discussing t-tests, dealing with intervals in Excel and SPSS in a while. So I hope you learned something. I hope you purchased the book. It should come out end mid February or end of February 2024. And as I've said, you can always reach out to me and we'll find a platform that we can talk and discuss about your variables, your hypothesis, and your null hypothesis. And that's it. So thank you and have a good day.